Web DDoS versus Radware. Who do you think will win? Do you even know what a Web DDoS attack is? In this video, we'll show you exactly what a Web DDoS attack is, how these attacks, sometimes referred to as tsunami attacks, target your web servers, but more importantly, how Radware is uniquely positioned to mitigate these attacks. So, let's jump in and get this game on. Welcome to Radware's Versus, where I'll show you how Radware can protect against the most advanced threats. My name is James, and my job is to show you how Radware can simplify protecting your online presence. A Web DDoS attack, more commonly referred to as a tsunami flood, is an encrypted attack that aims to overload a web application by sending a high volume of requests per second to the web server. This overwhelms the server and takes it and the application offline. Now that you know what a Web DDoS attack is, it's important to understand why this type of threat is so problematic. For starters, the traffic is encrypted. In order to understand what is happening to the web server, the traffic must be decrypted. Second, the traffic appears to be genuine. Third, hackers have access to advanced tools that can mimic valid TLS connections. And finally, hackers leveraging those tools can even evade the most advanced Layer 4 and Layer 7 authentication challenges. So what does this mean? It means that traditional detection and mitigation methods just won't work. Something more advanced is needed. Let's see what Radware can do. Let's open the browser and head over to console.radware.com. Take a few seconds and pause the video if you need to study the demo topology. Alright, we're on console.radwarecloud.com. We're on the overview page or the dashboard looking at the demo account. But let's take a look at the site that is going to be attacked here, autodemo.radware.net. And as we can see, the site is up and operational. There's no attacks running right now. We can navigate around. Everything's working just fine. Back in the portal, let's take a look at the assets. Let's go to the assets area here. And let's take a look at autodemo.radware.net. Let's click here. And that lands us on the details page. And on the far right, we can see the Web DDoS protection is enabled and blocking. Now we can click on this gear icon, or we can go directly to the tab here. I'm going to click on this tab here, and that's going to take us to the Web DDoS protection. And as you can see, there's a learning period here. It's pretty self-explanatory. You have several options: day, week, month. It defaults to a week. We're in a day for the demo environment. But we also have start under attack mode for emergency onboarding for customers that might be under attack. So we can waive the learning period and go right into learning mode and right into protection mode. The detection sensitivity level, there are several options here. The detection sensitivity determines the level of change between the normal baseline and the real-time values. The lower sensitivity means higher attack thresholds and a bigger change from the baseline, while higher sensitivity levels mean a lower attack threshold and smaller change from the baseline. Moving on to the mitigation sensitivity level, several options here as well: low, medium, high. That determines how aggressively the system mitigates the attack. So a low sensitivity level is the least aggressive, at the risk of allowing more attack requests to pass through, while high sensitivity drops requests more aggressively with the risk of legitimate traffic drops. Moving on to the minimum requests per second, the setting defines the minimum requests that can potentially trigger an attack. The default and recommended setting is around 500 RPS. Attack detection will not trigger if the real-time RPS is below the specified amount of the RPS here. you've got the RPS rate limit. This setting is used to limit the total request rates towards the origin as a fallback measure to ensure server health when the Web DDoS protection fails to fully mitigate the attack. This limit is enforced per the point of presence. You have the attack grace period. That's the time since the attack was terminated. Actually what happens is you also have the termination threshold. So when the threshold drops below the percentage and then meets the grace period time frame, then the attack is considered over, and we will no longer cache the actual footprint. And so if the attack starts up again, we'll have to relearn. Whereas if the attack starts up before the grace period, then we can continue using the same footprint. All right, let's go ahead and take a look at some of the attack details. Let's go to the security events page. And let's head over to the Web DDoS Protection tab. And as we can see here on the far right, there is now an ongoing attack. And if I head over to the web server, I can just hit the refresh page and you can see it's up. I can still navigate around. Everything's working perfectly fine. But let's jump back in the portal and kind of expand this ongoing attack against autodemo.radware.net. And let's take a look at some of these details. So you can see some pretty pertinent information here. Obviously the account ID, the attack ID, application, account, security module, the attack vector. Obviously it's an HTTPS attack, but you can see that the status is ongoing and if we're actually blocking the attack or not. More importantly, as we move across the page here, you can see the rate, the request rates. Now we have an attack threshold of 216 requests per second in this demo, and we can take a look at some of these by selecting and deselecting the legend items here. So we can see the attack threshold here at 217. We can see the clean traffic coming in, and then we can see how much traffic's being blocked or mitigated. And we can see the attack start value, right? That was 518 requests per second. Now, the application behavior below this, these are things that we're tracking, what we consider rate and variant parameters, like the request size, response size, the query arguments or parameters, cookies, headers, URL, geo. These are things that we use to track the application behavior as a rate and variant. So for example, if the request per second rate was higher than the threshold, but the behavior threshold was still below, in this example, below 3.9, this would be considered legitimate traffic. It could be a marketing campaign, something like that. It could be completely legitimate traffic. This is what allows us to become to minimize the false positives. But as you can see in this example, the start value is 6 on the application behavior, and as we see the behavior right here on this chart exceeds 6, you can see the traffic ramps up. And this is where we start kicking in mitigation. You see the spike drops, and we can see the real-time signature being generated here. Now, also above this, you see your total request average values, but you see your maximum values as well. We saw up to 41,000 requests per second. But this real-time signature, number of path elements, HTTP method, query arguments, cookies, standard headers, cache, does the cache exist? There's so many parameters that allows us to get very granular with that detection. So that's really key in minimizing the false positives. And really that's all there is to the solution. Really, with the most advanced detection, the highest accurate mitigation, horizontal scalability, the tsunami flood has no chance. Radware is a clear winner here. Thanks for watching. Please like, subscribe, and comment, and don't forget to click that notification icon for that next video. So you don't forget to let Radware help you get your game on and protect your online presence.